So look at your formula sheet, and we're going to start with the review. Numbers 1 through 3, it says simplify each expression by writing it in terms of one angle. Okay? So these are the problems that when you're finished with it, you're going to get either, for example, maybe sine of 20. Okay? And if what you get is on the unit circle, you'll go ahead and write the answer to it. Now if you look at your formula chart, you can look at all of these. Sine, cosine plus, cosine, sine. Okay, this is the 1 minus, and this is the tangent. That's these. So that's the front. Okay. And number 1 is sine, cosine plus, cosine, sine. Which one of these does that match? Which one? Sine alpha plus beta, good. So it's this one. So this means, actually, sine of alpha plus beta, remember? Well, 75 is alpha and 15 is beta. So what's 75 plus 15? So all I'm asking for then is sine at 90 degrees. Now use your unit circle. Is 90 degrees on our unit circle? Absolutely. So find 90 degrees. What is sine at 90? 1. So the answer is 1. Okay, I'm going to give you a minute or two now to do number 2 and 3 the same way. And then I'm going to turn this back on and I'll write the answers for you. Try that. Okay, the one that matched number 2 was sine of alpha divided by 2, correct? Okay, what's alpha in this case? What degree is alpha? 70. So 70 divided by 2 is 35. So sine at 35 degrees. Is 35 degrees actually on the unit circle? No. So that's just your final answer. If it's on the unit circle, you go one step farther and find sine at 35. Now then, we'll get number 3. What did you guys get for number 3? What'd you get? Yeah, if you got root 3, that's perfect. The formula was tangent of alpha plus beta, okay, which means tangent of 45 plus 15. So you have tangent at 60 degrees. And 60 degrees is on the unit circle, so therefore the answer is root 3. Okay. Now we're going to move to a different type of problem. Go down to number 4. Number 4 says find the exact value of each trig function. And you'll notice that it's already written. Cosine 105, sine 15, tangent 195. Remember when they're shrunk, our job is to expand. When they're expanded, our job is to condense or shrink. So these are condensed. So you're going to look at your formulas again and say, okay, cosine of 105, and I'm going to expand it. These are the two that are the cosine. You can either add to come up with the angle or subtract. What ways could I rewrite 105? It's better to be on the unit circle. What would work? 60 and what else? 45. So I would rewrite this as cosine of 60 plus 45. And then I'm going to use my formula to expand it. Cosine, cosine, minus sine, sine. Correct? It's the opposite. So you're going to say, okay, cosine of 60 times cosine of 45. We write minus sine of 60, sine of 45. What's my next step then? That's why I was saying you probably needed your unit circle. If you don't have it, you need to get it out. Okay. What is the value of cosine at 60? That's, cosine, remember, is the x value. What's the x value at 60? What is it? Okay. So you're going to say 1/2 times. Remember, we do this part first. We multiply, then we add. So now what's cosine at 140, I'm sorry, cosine at 45? That's the x value at 45 degrees is root 2 over 2 minus sine at 60 is root 3 over 2, and sine at 45 is root 2 over 2. Okay, like I said before, you have to multiply, you have to multiply these together and these together, and they're fractions. So top would be root 2 and the bottom would be 4. So root 2 over 4 minus, what is root 3 times root 2? Good, root 6 over 4. They both have a common denominator, so to clean it up, we just wrote root 2 minus root 6. And that's how you would leave your answer. Now, I want you to try 5 and 6. Now, the answer to number 5 was root 6 minus root 2 over 4. So the root 2 should have been negative, the root 6 positive. The problem is you may have chosen different numbers than me to have done the problem. So I'm going to choose sine of 45 minus 30. If you did something different, that doesn't make it wrong. Okay, but when you expand it, that's sine of 45 cosine 30 minus sine of 30 cosine of 30. Root 2 over 2 times root 3 over 2 minus 1/2 times root 2 over 2. Remember to do this part first. So you end up with root 6 over 4 minus root 2 over 4. Final answer being root 6 minus root 2 all over 4. Now, if you have a minus, you wrote minus root 2 plus root 6 over 4, then that's the same exact answer. Okay, it's not incorrect. Okay, the next one says tangent of 195. I'm out of room on here, so let me write it here. Tangent of 195. The answer was kind of complicated. The answer was negative 1 plus root 3 over 1 minus root 3. Keep going 2 times. Did you do it right? Okay, it depends on what you chose. The tangent of 135 plus 60 is what I chose. So you're going to have tangent of 135 plus tangent of 60. Remember the secret here? Only use problems that have what as a tangent? What's the secret? Yeah, only use tangents with 1 and root 3. Only. That's why I chose 135 and 60. And then 1 minus tangent of 35 times tangent of 60. The positives on top. So you end up with negative 1 plus root 3 over 1 minus root 3. Okay?
Yeah, when you do 1 plus root 3, and on the bottom you're multiplying both of them, it'd be a negative.
The bottom's negative.
But it would be positive. Because you have to multiply the
Oh, because that's negative. Oh, okay, yeah. Thank you. Okay, now then let's move to the next problem. Where are we at, guys? Number 7? Okay, let's look at number 7. Can you do me a favor? With your pen, I want you to add some data, okay? Listen real quick. I gave you information about alpha, but I didn't give you any information about beta. So why don't you say cosine of beta is 3/5. Can you add that in for me? Cosine of beta is 3/5. And then I want you to also say that alpha is this way and so is beta. Alpha and beta are both in quadrant 1. There wasn't enough information to do the problems that are given. Okay, so did you add that? Cosine of beta is 3/5, and beta is between 0 and pi over 2. That means quadrant 1, doesn't it? Okay, remember to do these kind of problems, we had to set up our triangles first, right? Okay, and these are all in quadrant 1, so they're gonna be easy to set up. Let's set up sine first. So let's set up alpha. So here's alpha, and remember you start in the center and you go out and come down. Remember? And what is sine? Opposite over what? hypotenuse. So opposite of this angle at the origin, that's the opposite I want, right? Opposite. So opposite is 12, the hypotenuse is 13. And in your calculator then do 13 squared minus 12 squared. Right? Take the square root, what's it going to be? 5, good. Okay, I'm going to give you a second to set up beta now. You set up beta. Try it. Cosine is adjacent over hypotenuse, correct? So this is at A and H. Adjacent is 3, hypotenuse is 5. What's the other leg? 4. Okay, let's look at number 7. Use your formula chart. Number 7 says cosine of 2 times alpha. Okay, find cosine of 2 alpha on here. How many different options are there, guys? Cosine 2 alpha, cosine 2 alpha, and cosine 2 alpha. Does it matter which one we use? No. I'm going to use the middle one. Okay? So 1 minus 2 sine squared. I'm going to use 1 minus 2 sine squared alpha. That's the formula I'm going to use. So if I plug it in, 1 minus 2, what is sine of alpha? You got to use that first triangle. Good, opposite over hypotenuse, 12 over 13. Don't forget to square it. Type that straight in your calculator. And then do math, enter, enter. Straight in your calculator, math, enter, enter. You should get negative 119 over 169. Okay, I'm going to give you a few minutes to try 8 and 9. Yeah. Number 8, sine of alpha over 2. This is the formula you're going to use for it, right here. So the square root of 1 minus cosine of alpha over 2. So all you need is cosine of alpha, which is 5 over 13. So it's the square root of 1 minus 5 over 13 divided by 2. But you have to clean it up. You don't want to leave it like that. So 1 minus 5 over 13 is 4 over 13. If you type just this part in your calculator, okay, leave out the radical. Don't put the radical in your calculator. Okay? Just put in what's under it. Just what's under it. So 1 minus 5/13 over 2. Math inner, you get 4/13, right? So that's what this is. But isn't 4 a perfect square? Okay, so technically you get 2 over root 13, but if you don't leave your radical in the denominator, you get 2 root 13 over 13. Okay, because of time, I'm going to stop on that one, but number 9 was negative 120 over 119 if you did it. Okay, so you can check it. Number 9 was negative 120 over 119 if you want to check it. Okay, go to number 10. I'd like for you to try 10. Alright, so if you're going to expand sine alpha plus beta, that's this, which means you want to use this formula right here, the very first one. Okay. So if I write that, sine alpha, cosine beta, where am I going to get these values from? Cosine alpha, sine beta. Good. They come from my triangle. You have to go and find alpha and find sine of alpha, which is 12/13. Then you have to look at your picture at beta and find cosine at beta, which is 3/5. Then find cosine at alpha, which is 5/13. And sine at beta, which is 4/5. When you get that part, you just type it straight in your calculator, the whole entire thing. Okay, type in the whole thing, and you should get 56 over 65. That's the final answer. Okay, now for number 11, it's kind of the same. I'm going to give you the answer, negative 33 over 65, if you want to go back and try it. And 12 is 16 over 65, if you want to go back and try it. These are good problems to do to get yourself more ready.
Isn't 12 the same sign?
Oh, it's a typo. It should, okay, thank you. Change number 12 to a minus. Thanks. Number 12 should be a minus, and when you do a minus, you get 16 over 65. Thank you. Okay, it has been a long time since we've done a problem like 13, but if you're taking the final, there's one like it on the test. So read 13 to yourself for a second. Okay, for this triangle, you have an eagle. So here's the eagle up high, right, guys? And there are two people on the ground that are 9 miles apart. So they're looking at the eagle, one guy from this side and one guy from this side. And it says the angle of the elevation from one observer is 58, so we'll put a 58 here. And the other is 32. Can I find that missing angle? Absolutely. So do 180 minus 58 minus 32, and the other angle is actually 90. Okay? And the question says, how far is the eagle from each observer? So you have to find two things. Let's start with this one, A. Well, we can use law of sine, and I even have law of sine on your formula sheet on the back, because I know it's been a while, but the back has the law of sine formula. It's the easy one. Okay? So I know that sine of 58 over A equals, you can only have one variable, so which ones are you going to put together? What does the other one have to be? Sine of 90 and what? 9. Because you can only keep one variable. That's going to find A for you. Now, watch your calculator, but this is going to need to be in degree mode. So, in your calculator, I don't know if you remember, but turn it on. Go to hit the mode key, which is next to the second. Go down and over. There's the degree. Hit enter, and then you can second quit back out. Type this in. Sine of 58, you work at triangle. Remember sine of 58 times 9. Close the parentheses at 58 or it won't give you the right answer. Okay, hit enter. Then you're going to divide by sine of 90. Yeah, I'm sorry. So A is 7.6. Okay, so now we have A. We also wanted B. So use the same formula, but find B. Sine at 90 over 9 equals sine of 32 over your missing side B. Type in your calculator, see if you can get the right answer using your parentheses like you're supposed to. What did you get? Yeah, 4.7. So 4.8. So B is 4.7. That's your two answers then. Okay? Go to number 14. Given the right triangle ABC, angle A is 29 and side A is 15. What's the length of the hypotenuse? Because it's a very, very easy problem. Okay? Draw a triangle first for me. Let me let you do that. Draw a right triangle. I want to know the length of the hypotenuse. Guys, can I use law of sine for this problem? Do I have an angle and a matching side? Okay, check and see. Here's your right triangle. Okay, angle A is 29. So then this is 15. It wants this. Can I use the law of sines for this? Absolutely. Okay, sine of 29 matches which side? 15 equals sine of 90 to find the missing side, x. That works great. Use your calculator and see if you can get the correct answer. Guys, you have to enter it in the calculator correctly. Try it. Don't forget to put parentheses around the 29. Okay, 30.94, and that's it for today.